Kokming. Today we talk about power rule in calculus differentiation. From our previous video, we observed this result that is given this particular functions, we found the derivative to be such. And the last one is that if the function is a constant m, then I found that the derivative here is 0. And that makes sense because for a constant, your function is basically like it's a horizontal line, and then at any point on the horizontal line, the gradient is 0, is flat. Now looking at this, can you make some observation? Very good. That is, you see that the observation here is this. That is, the power here, right, when you take the derivative, appears to go down, to go to the front of the coefficient, and the power is reduced by 1. So 2 minus 1 is 1, and then 2 times 3 is 6, for example. And here, similarly, 2 goes to the front of the coefficient, become 2x, and the power is reduced by 1. So 2 minus 1 is 1. Here, similarly, x, you take the derivative of that, it becomes 0. And 2 here becomes 0 because constant, the derivative of constant is 0. So what we found then is this. That is, we have power rule is this. If you have y equal to a function, f of x is a polynomial function, that is, if you have a what we found is that if my y is equal to ax to the power of n, where n is a real number and a is also a real number, then what I get is that if I take the derivative, the power goes to the front, ax, and then the power is reduced by 1. And this is what we call the power rule. Y dash in this particular case is 6 times 3. 6 is the index comes down, Humpty Dumpty comes down, and then the index is reduced by 1. So what we have is 18x to the power of 5. And we are done for this one. The second one, b, this, you probably want to rewrite this as x to the power of half. And then in this particular case, y dash in this case is half. The index comes to the front, become the coefficient, and the index is reduced by 1, so it's half minus 1. So the answer is half x to the power of negative half. Or better still, you write this as 1 over 2 square root of x. Now, in the IB exam, it doesn't really matter if you give your answer like this or like that. Unless it's specified, you don't really have to put it in the later form. And some students actually prefer the later form as square root of x over 2 of x. I mean, if you want to rationalize it, this is also okay. Again, we may want to rewrite this as square root of x is x to the power of half, and then use index law. This is x to the power of 3 half. This is y. And then y dash, make sure that you write your notation carefully, y and y dash, and not just y, for example. And then the index goes to the front of and becomes the coefficients of x. And then the index now is reduced by 1, so it's 3 half and x to the power of half. Or you can write this as 3 half square root of x, and that's the answer. This is y dash mixture. Here again, you may want to rewrite the questions as x to the power of negative 2. Then using the power rule, the power comes to the front of and becomes the coefficient, so it's negative 2, and x, the coefficient, the index is reduced by 1, so this is negative 2 x to the power of negative 3, or better still as negative 2 divided by x raised to the power of 3, and this is the answer. Now let's check our answer. So A, y dash in this particular case is power comes to the front, and then the power is reduced by 1. So the answer to this is 15y dash, 15x to the power of 2. Question as x times x to the power of negative 1/2. Using index law, y is equal to x to the power of 1 minus 1/2 is just going to be half. Then y dash in this case is just going to be the power comes to the front, and then the power is reduced by 1. So y dash in this case is equal to half times x to the power of negative half, or 1 over 2 square root of x. C, I don't have to do much. So power comes to the front, becomes coefficient 1/3, and the power is reduced by 1, 1/3 minus 1. So this is 1/3, y dash is equal to 1/3 times x to the power of negative 2/3. So you can also rewrite this as y dash is equal to 1 over 3 x to the power of 2/3 is equal to x to the power of negative 4. So in this particular case, y dash is negative 4. The power becomes the coefficient now, and x to the raised to the power of negative 5. Negative 4 minus 1, negative 5. Or you can rewrite this as negative 4 over x to the power of 5. And that's it. Did you get everything right? Excellent.